welcome to this soil lab. So last week you have performed a test on consolidation to evaluate the compressibility parameter that is associated with soil, which is a very important issue because you need to evaluate settlement whenever you have to do, for example, design of foundations, etc. So today we are going to evaluate another engineering parameter, which is very important in design, geotechnical design, which is shear strength. So first of all, shear strength is the maximum stress that can be sustained by the soil. So shear strength should have the same unit as shear stress. In laboratory, there are many tests to determine the shear strength of soil. The most common test would be direct shear test, triaxial test, and if you go to graduate schools, you may know other tests that can help you evaluate shear strength. But for undergraduate study, we are going to focus on direct shear test and triaxial test. Okay, so today we are going to perform direct shear test, and in the next lab we are going to perform triaxial test. For shear strength, it is important to know that the value of the shear strength would be dependent on how you apply the loading. Okay, so as what you expect, okay, if you evaluate the shear strength by direct shear test, the shear strength parameter that you are going to obtain may be different from the shear strength parameter that you would obtain through triaxial test. Okay, so the loading condition will be important, okay, in terms of shear strength. So you should find the most appropriate loading method, okay, in order for you to obtain an appropriate shear strength value. Okay, so in the lab, what we're going to do is to determine the shear strength parameters, which are cohesion and friction angle. Okay, in a moment, we are going to take a look at the principle behind cohesion and friction angle. All right, if you look at this illustration here, I have a slope and then also a foundation, which you will learn in the next semester. To illustrate what shear strength is, basically, as what I mentioned a moment ago, shear strength should be the maximum shear stress that can be sustained by soil. If you look at this slope here, when it starts to fail, if you look at this pink arrow here, this pink arrow basically indicates or representing the shear strength of soil because it tries to resist. It tries to resist the downward movement of the slope. Likewise, if you have to evaluate the foundation, okay, you will have to evaluate you will have to use the shear strength parameter to help you evaluate the bearing capacity failure of your foundation. Both of them involve, okay, the usage of shear strength parameters. So for today, we're going to use direct shear test. The setup is very simple compared to the setup of triaxial test. Okay, this is the illustration for the experimental setup. So basically, you have a shear box. Okay, you have a shear box, and then within the shear box, what you have to do is to use some grid plates. Basically, the grid plates are the plates with some indentation, and then also there will be some pour stone. Okay, pour stone will be put at the bottom, and then we will put the grid plates, and then you will put the sample, and then at the top of the sample you will have grid plates and pour stones again. So for the test, okay, to run the test, what you have to do is to apply some vertical load. Okay, so we will call this P, which is the normal load that is applied to the sample. And then in addition to that, we will apply horizontal loading to the shear box. So what you would expect is, for a given normal load, you will need to keep track of the horizontal movement and then also the vertical movement of the sample. Indeed, what you have to do for this test is you will have to record all of these values. So those values will be vertical displacement, or vertical strain, normal loading, and then horizontal loading, and then also horizontal movement or horizontal strain. All of these will be important when you need to come up with the shear strength parameters. So, so first of all, okay, from your high school physics, what you may have studied is the concept of friction. Why do we want to talk about that? Because it is similar to the principle of the friction that exists within the soil system. So if you remember from high school physics, if you have a body that is resting on a surface, you will need to evaluate when the box can start to move. Okay, then basically what you need to do is if you have to tilt this surface here, okay, same block here, the angle at which this block starts to move will be basically the friction angle that we want to keep track. Okay, so the F here would be the frictional force, mu is the coefficient of the friction, and then N is the normal force. If the normal force is larger, then the friction will be larger, okay, because it is proportional or related by the constant mu. Okay, so you will need to evaluate mu for different kind of surfaces. Okay, so it depends on the interface between this block and then also this tilted surface. For soil, it's kind of similar, but what you may want to remember is for soil, we're not talking about the friction in between two surfaces. Instead, we're talking about the friction within the soil system. So basically, it will be the friction between soil particles. So because of that, when we describe the friction, we will call that friction angle internal friction angle, because it is used to describe the friction within the soil system, not just like the friction between two different surfaces that is made of different materials. Okay, so that will be the first difference, okay, between the soil friction that we are talking about in this class and then also the friction that you learn from high school physics. But the basic concept is quite similar. And then in addition to that, sometimes if you have a fine particle in your soil system, it may contribute to additional shear resistance. Okay, so those shear resistance is not related to the normal force or normal stress. It would be similar to putting some glue, okay, at the surfaces. So if you have some additional glue at the surface, then it will provide additional shear resistance. So we will use the cohesion to describe this type of shear resistance. Okay, so cohesion does not have to do with the normal force. Okay, so for this class here, when you perform direct shear test, what we are going to do is to apply different loading to the sample. Okay, so this P indicates the amount of loading. If you look at this graph here, for the test that you are going to perform, we are going to perform 1 kilogram of P, 2 kilogram, 4 kilogram, and 8 kilogram. Since my x-axis is normal stress here, on this axis you will actually need to divide by the area of the sample to change the unit into stress units. So basically, by applying different normal stress or normal load, we will need to obtain, okay, or evaluate the maximum shear stress that can be sustained by the sample. Okay, so when you look at that, you will report the maximum shear stress value. So they will be represented by this axis here. Okay, after you have done that, you will use a linear regression method to come up with this line, because if you look at this line here, the intercept will be corresponding to cohesion, okay, as what you expect. Okay, even if you do not apply any normal loading, you will have cohesion. And then for the slope of this line, it will be the friction angle. So if you remember from your soil mechanics class, this equation here is basically the mole Coulomb failure envelope. Okay, so that will be the equation that we are going to use to describe the shear stress. And then friction angle and C will be the shear strength parameters. In addition to that, in your soil mechanics class, you may have learned that different soil type will have different friction angle and cohesion. Even if you have sand, okay, the relative density of the sand would yield different stress strain behavior. Okay? If you look at this graph here, this graph basically plots the shear stress versus horizontal movement or horizontal strain. If you have dense sand, what you would expect is there would be a peak here, and then as you add additional shear strain or horizontal strain to the soil, the peak shear stress would actually drop. Okay, but for loose material or loose sand, what you would see is it will monotonically increase, and then it will have a plateau, okay, at the end. Okay, so when you perform your test today, you will need to decide what type of sand you have, because again, depending on the relative density or denseness of your material, you will have different stress and strain behavior. Okay, if you look at another plot, which is a plot of vertical strain versus horizontal strain, I mean, what you will see is for dense material, you will first expect a small compression, okay, represented by the negative volumetric strain here. And then what you will expect later is there will be some expansion if you keep on applying horizontal loading, or if the horizontal strain increases. And for the loose material, what you expect is you will only have negative or contraction of soil when you perform your test. So this kind of plots will help you determine whether you have a dense sand or loose sand. So when you perform the test, you will need to check this graph as well. So what we're going to do now is to demonstrate how you can set up the shear box, how you can set up the specimen, because I mean, even though the experimental setup is quite simple, it may take a lot of techniques for you to come up with accurate reading, okay? Because those reading controls everything on how you can determine the C and then also the friction angle. Okay? So pay attention to the TA when she teaches you how to read those full readings.